d square y by dx square is derivatives d by dx of dy by dx. Derivative ka derivative. In that case, you need to practice with me these many questions. So write down d by, you have written the heading higher order derivative or second order also will do. Higher order derivative. Then first you write this notation d by dx of dy by dx is denoted by d2y by dx2 or d square y by dx square, anyhow you read. So now you tell me how to find derivative of dy by dx the whole square. What rule will you apply here?
The power rule.
Power rule. So what will be your answer?
2 into dy by dx.
2 dy by dx into derivative of dy by dx, which I can write as 2 dy by dx into d2y by dx2. I hope you understood. Is it clear? Another notation is y1 we write as dy by dx. y2 if you see it is d square y by dx square. y3 means third derivative. Another method is y dash is dy by dx. Y prime you call it. Double prime is d2y by dx. So these are the notation. This notation sometimes we use this notation. All means the same. So some question you may find in today's exercise like this notation. You should understand that it is same thing only. Okay, now next practice. I hope you have written the first one. Okay, now find the answer for this. d by dx of y dy by dx. How will I find the derivative of this? Y dy by dx. How many functions are there in the bracket? Y is one function. Dy by dx is another function. And between them, what is the operation? Multiplication. So we need to apply product rule. Y into derivative of dy by dx. I'm directly writing d2y by dx2. So, and otherwise I'll have to write this notation. Okay, I'll write that notation, but in the exam you don't have to do that. Directly write d by dx of dy by dx plus dy by dx into derivative of y. Derivative of y again, one more dy by dx will come. So my answer became y times d2y by dx2 plus dy by dx whole square. Have you understood? I want you to get more used to this type of stuff. d by dx of log of dy by dx. Write your answer. One of you speak out the answer. Log of dy by dx.
dx upon dy.
Into what is derivative log u?
1 upon u.
1 upon u into derivative of u is there.
Derivative of u.
So that also you need to apply. So 1 upon dy by dx into derivative of dy by dx. What is derivative of dy by dx? 1 upon dy by dx into d2y by dx2. Have you all understood? So you treat always dy by dx as a function of x. So whenever you are applying any rule, you have to treat it as a u, that what we used as notation u, that way you have to treat it. And if you find derivative, directly you can use the notation of d2y by dx2. Last one more. Fourth one. d by dx of the root of x square plus 1 into dy by dx. Can you do it yourself? Which rule will you apply here?
Product rule.
Product rule. Okay, I'm giving you some time for you to write yours. Find the second order derivative. Of following functions. First one, 2x raised to 5 minus 4x cubed minus 2 by x square minus 9. You have to find the second order derivative of this. You will start with let y equal to. Two by x square, I'm writing x raised to minus 2. Now find the first derivative. What are the different notation that I can use? If you don't want to use dy by dx, you can use y1, you can use y dash, you can use dy by dx. Any of these three notation you can use. So I'm using our old notation dy by dx. 2 into x raised to 5 derivative minus 4 into 3x square minus 2 into minus 2x raised to minus 3. So 10x raised to 4 minus 12x square plus 4 by x cube, or 4x raised to minus 3. Now you are asked to find the second order derivative. So if differentiate again with respect to x. So you can write d square y by dx square equal to 40x cube minus 24x minus 12x raised to minus 4. 40x cube minus 24x minus 12 upon x raised to 4. Is it fine?
Yes, sir.
Okay. Do yourself next problem. Question number 2. Y is equal to e raised to 2x into tan x. Find the second order derivative. So dy by dx is e raised to 2x into derivative of tan x plus tan x into derivative of e raised to 2x. So take e raised to 2x common. 6 square x plus 2 tan x. Again differentiate with respect to x. D square y by dx square. Again apply product rule. E raised to 2x. Tell me derivative of sec square x
2 sec
into derivative of sec x. 2 tan x derivative 2 sec square x plus 6 square x plus 2 tan x into derivative of e raised to 2x. Now first you take e raised to 2x common. 2 6 square x into tan x plus 2 6 square x plus 2 6 square x plus 2 tan x. So you can write your answer as e raised to 2x 2 6 square x into tan x plus 4 6 square x plus 4 tan x. I hope you understood. What you notice in this problem is the function has e raised to m tan inverse x, but the answer does not have e raised to m tan inverse x. Second point to notice, the answer has got second derivative. So you need to differentiate twice. Usually your mind will work like this. Find the first derivative, find the second derivative and substitute here. But don't do that way, that will be very lengthy to solve. Even if you do it that way, it's correct. But I don't know how much steps should be taken. What you have to do in this type of problem is, you need to eliminate this term from here. This term should not be there in my answer. So first you differentiate with respect to x. Even if you take log and differentiate, no problem. Or if you are not taking log, directly differentiate also will do. So e raised to m tan inverse x into derivative of m tan inverse x. No problem, no? Has anybody got any difficulty there?
No,
E raised to u derivative. So that became dy by dx. I don't want this to be present in my answer, so I'll substitute as y into m times derivative of tan inverse x, 1 plus x squared. Now, this much is our usual method. There's not much difference here. Now, whenever you are given such format to prove, always cross multiply. Cross multiply. Again, differentiate with respect to x. This is an important step. This is a new step that you have learned. Never keep anything in the denominator when you do second derivative, because it will become very complicated to find the second derivative. So always cross multiply and differentiate. This is an important step. Note this step. Which step? This one. What you have to note? After the first derivative, remove the term which you don't want and then cross multiply and differentiate. And you will directly get this answer. So when you differentiate this, you will have to do product rule. I hope you are paying attention here.
yes, sir.
This is the only new thing I have taught you. After the first derivative, cross multiply and differentiate. So when you apply the product rule, 1 plus x square into dy by dx derivative, that is second derivative, d2y by dx2, plus dy by dx into derivative of 1 plus x square, that is 2x, is equal to m into dy by dx. So bring this to left hand side and you got the answer. Is it fine? Is it clear to everybody?
Yes.
Yes.
What are you planning to do in this problem? Speak out. Whatever comes in your mind, tell me. How will you proceed this problem?
So first we find dx by dt, then dy by dt, then
Chirag, did you notice that the answer does not contain t terms?
yes, sir. Then dy by dx.
So don't you feel it will be better that my answer should not have t at all?
Yes, sir.
So we have two options. One option is your method. Find everything in t and substitute it and show LHS equal to RHS. That's one method. Second method is remove the t from the beginning only and find the derivative. Both the methods are okay. There's nothing wrong in any method. But if you replace t, remove t from here. How to remove t from here? Your t can be written as cos inverse x. And put that cos inverse x over here. So t will get removed. Second method, take log on y and replace t as cos inverse x. That also will find. I'm using this method. T is cos inverse x. Therefore, y is equal to e raised to m cos inverse x. Is it fine with everybody? So it became similar to this problem. Hardly any difference, this and this. Have you noticed that? So whatever the method you applied in the previous problem, you need to apply in this one. Either you can take log or differentiate once and substitute y. Anyway, any method is fine. So let's do that method. Is it clear, everybody?
Yes.
Yes, sir.
So this is equation 1. This is equation 2. Substituted 1 and 2. Why did you do this idea? Because the answer does not contain t. So eliminate t before you differentiate. So now you will differentiate with respect to x. So dy by dx is equal to d by dx of e raised to m cos inverse x. E raised to m cos inverse x into derivative of m cos inverse x. So dy by dx is equal to e raised to m cos inverse x is nothing but y into minus m upon root 1 minus x square. Now cross multiply root of 1 minus x square into dy by dx is minus my. Is it fine? Why did you cross multiply after this derivative? Tell me what is the reason for cross multiplication?
So it
That
will
while
become
we take the
complicated.
second order derivative, we don't have a problem.
Yeah, whenever you do second derivative, you should not keep anything in the denominator. U by v method will be complicated. That is only the reason, nothing else. It is not that you will not get the answer. You'll get the answer. Anyhow you do, you'll get the answer. But we need to reduce the complication. Now what are you planning to do after this? Two options with you. You can square and differentiate, or you may differentiate directly. If you square and differentiate directly, you will get this answer. If you don't square, you'll have to substitute. What do you mean by substitute? After the first derivative, you have to replace this dy by dx. So I'm going to square. This format doesn't change in any problem. When there's a square root, you square it. Square. Now differentiate this again. We'll have to apply product rule. Okay, I'll write one step like this. If you apply product rule, 1 minus x square into derivative of dy by dx whole square. 2 dy by dx into derivative of dy by dx. Is it fine? This is why I trained you this before. U into derivative of v. V into derivative of u is m square into derivative of y square. 2y derivative of y. Any problem? So these steps are quite fixed in every problem. So if you practice 10 problems, you will get the idea of how to go about this. The format of the second derivative remains same in every problem. Now I'm going to tell you one interesting part about it. Whenever you square and differentiate, that is second here is squared it, no? You will find that left-hand side with right-hand side will have a common term. And that common term will be 2 dy by dx. Fixed, every problem. Whenever you square and differentiate, 2 divided by dx will be a common term in both the sides. So 2 I have taken common. So x 1 divided by dx also has gone. Now just cancel off this 2 divided by dx from both the side, and that is your answer. So that is a benefit of squaring and differentiating. Whenever you square and differentiate, there'll be a cancellation 2 divided by dx, and after you cancel, it will come back to this question. So your answer became 1 minus x square into d square by dx square minus x divided by dx minus m square y equal to 0. I hope you can read it. So y is m log x plus root of x square plus a square. Now differentiate with respect to x. So derivative of y divided by dx m into 1 upon x plus root of x square plus a square into d by dx of x plus root of x square plus a square. So dy by dx will be m upon x plus root of x square plus a square. When you differentiate this x, it becomes 1. When you differentiate this root, 1 by 2 root x square plus a square into 2x. A square derivative will be 0. So dy by dx will be m upon x plus root x square plus a square. When you take LCM, root of x square plus a square plus x divided by root of x square plus a square. Fine. This is a speciality. This and this will get cancelled. Please don't forget this. Whenever you see this function, you must remember of this cancellation. Then only you will be able to understand. Otherwise, you'll make some mistake you won't remember. You will not be able to come to that conclusion. So dy by dx became a very small term, m upon root x square plus a square. Can you tell me what is the next step?
So we will transfer the root to the other side.
Yeah, we'll take the denominator to the right hand side, left hand side. Then after that,
So we will square it.
square it. Then what after that, differentiate it. After that, there'll be a cancellation. In this problem also, I think there's a cancellation. Yeah. Is it fine? I think so. Anyway, let's see. Cross multiply root of x square plus y square a square into dy by dx equal to m. Square it. In this, there'll be no cancellation because there is only one term. Okay, let's see. Now differentiate again. Now apply product rule. X square plus a square into derivative of dy by dx whole square. So 2 dy by dx into derivative of dy by dx plus dy by dx the whole square into, okay, I'll do one thing. I don't want to, I'll cut this down. Otherwise, later on you may not understand. D by dx of dy by dx the whole square. If you have written already yourself, then no problem. This is by chance you are reading it later, you should not have a problem. Derivative of m square will be 0. Now we'll write directly the answer. 2 dy by dx into d2y by dx2 plus dy by dx the whole square into 2x equal to 0. Yes, like last time, here also there is a common. 2 dy by dx is common. So x square plus a square into d2y by dx2 plus x dy by dx equal to 0. Now this part will go to the denominator. Therefore, x square plus a square into d square y by dx square plus x dy by dx is 0. Second, dy by dx is not a 0 term. That's why this function has been cancelled. I hope you got the technique of doing this problem. What you do is, the answer does not contain neither sine nor cos. So transfer the sign to the left-hand side. Now if you differentiate it, derivative of sine inverse y don't have sine or cos. So if you differentiate this, you will get the terms that is present in your answer. 1 by root 1 minus y square into derivative of y is minus m upon root 1 minus x square. Now cross multiply, square and differentiate it, you will get the answer. I want you to do yourself at home. Now square, then differentiate. Is it fine? I
Yes,
hope you
sir.
understood why I have taken this sine inverse to left-hand side. See, logic behind everything you should understand. Otherwise, you won't get the idea. You will get confused in the exam. Why sometime I'm taking sine inverse, sometime I'm taking dx by dt. You have to understand why we are doing that. If I directly differentiate it, the answer will turn to cos. And this cos term are not present in my answer. So it will make my answer more lengthy to come into the answer. Now again I have to cross multiply, differentiate again, then cos will change to sine, and then I have to substitute y. That would be the method if you do directly. But that is a too lengthy method. Instead, if you transfer the sign to left-hand side, then if you take derivative, this cos sine it get eliminated as by itself. Will get eliminated by itself. Is it clear? Understood or not? Did not understand.
Yes, sir.
Yes, sir.
Yes, sir.
After you finish this much writing, remaining you'll complete yourself and let me know in next class.